Okay, guys, welcome. Today we're going to talk about some identities that involve the inverse trigonometric functions. So we're going to talk about how we can look at the composition in either order of a trig function and its inverse. We'll talk about how to find inverses of functions that involve some trig functions. We'll talk about how to compute the composition of one trigonometric function with another trigonometric function, or the inverse, I should say, of another trigonometric function. And then we'll talk about some identities that involved negative angles and also the addition of arc cosine and arc sine. Okay, so first identity that we'll discuss is that if we take the composition of a trig function with its inverse trig function, then that's going to leave us with t as long as we have our domain for the inside satisfied, right? So as long as t is between -1 and 1 for cosine and sine, and then for tangent, it just needs to be a real number, right? So for example, oh, I'm sorry. And then the other way around, again, is similar, but here we just need our domain issue for the inside satisfied, right? So we need our restricted domains to be satisfied here so that we can talk about the inverse, right? So as a couple of examples, all right, if we want to find the inverse of cosine of 2 pi, well, let's take a look. We're going to get that cosine inverse of cosine of 2 pi. Well, we know that cosine of 2 pi, of course, is 0. And now, what's an angle whose cosine is 0? Well, if we look at our unit circle, and for inverse cosine, we need to just consider the top half of the unit circle. At what angle would that happen at? That's, of course, an angle of 0. All right. So here you need to be careful because the 2 pi would be outside of the appropriate domain, right? So we want our inverse cosine, in this case, to come out to be 0. Okay. Let's look at another example. So now let's suppose we want to find the inverse sine of sine of 380 degrees. Okay. Well, again, we're in a similar situation where if I look at sine of 380 degrees, this is the same as sine of 20 degrees plus 360 degrees, which is just the sine of 20 degrees. All right. So this puts our angle in its appropriate domain, because if we restrict our sine from -pi/2 to pi/2, or -90 degrees to +90 degrees, now 20 degrees is within that. Okay. So this then becomes equivalent to taking the inverse sine of sine of 20 degrees. But here we can just assume that we're going to get 20 here. All right, or 20 degrees, I should say. All right. So in this case, again, you want to make sure that these angles are within the appropriate ranges in order to get a correct value. Okay. Now, in the next example, we're going to suppose that we have a function f, which is 3 plus 4 cosine of x, where the domain of f is inside the interval 0 to pi. So again, that we can now talk about what the inverse is. So in part A, we want to find f inverse of x. Right? So of course, how do we do that? Well, we're going to set f of x equal to y in our original function. We'll switch x and y, so we'll make this an x, and we're going to make x into a y now. And now we need to solve this for y. So what we can do is we can subtract 3 from both sides, and we get x minus 3 is equal to 4 cosine of y. And then we can divide both sides by 4. So now we have a cosine of y is equal to x minus 3 over 4. And finally, we can now take the inverse cosine definition here, and we'll get that y is the inverse cosine of x minus 3 over 4. All right, so that's our formula for the inverse in this case. Okay, now for the domain and range, we can look at the domain and range of our original function, and then the inverse will have the opposite properties, right? So since the domain of f is 0 to pi, this is the range of f inverse. So the range of f inverse is 0 to pi. Right, and of course that makes sense because we have the inverse cosine of some angle. We don't really care what it is, but we know that the range of the inverse cosine is from 0 to pi, right? Now, for the domain, we need to know the range of f. Okay, now our original function f was 3 plus 4 times cosine of x. Now we know that cosine has a range of -1 to 1. All right, but we're multiplying that range by 4 and adding 3 to that. So if I multiply the interval -1 to 1 by 4, that's going to stretch it to -4 to +4. And then if I shift everything in that range up by 3, I'm going to get the interval -1. If I add 3 to -4, I get -1. If I add 3 to +4, I'm going to get 7. So this is the range of f. And since that's the range of f, that's the domain of f inverse. So the domain of f inverse is -1 to 7. Right? And of course, another way that you could do that is you could look at this inside here, and you would need that to be between -1 and 1. And if you solve this inequality, you're going to get the same thing because you'll get a -4 less than or equal to +4 once you multiply through by 4. And then if you add 3, you get -1 to 7 that way as well, right? So that's sort of another way that you could handle that one. Okay, and of course, this is just reminding you how to find the inverse function, but essentially we did that, right? So and again, this is just sort of another way of saying the steps that we did earlier. In general, you want to switch x and y. Once you've substituted y in for f of x, you'll resolve it for y, and what that's going to do is sort of undo everything that you've done to x. Okay, is this not the example we just did? 3 plus 4 cosine x. Yeah, okay, so we already did that one, so we don't need to bother doing it again. Okay, so the next type of problem is, what if I want to find something like this? I want to find one trig function composed with the inverse of another trig function. Okay, so now it's a little bit more difficult than just essentially saying we have, right, like just sort of undoing some numbers or something like that, right? So let's first worry about the inside. Let's look at the inverse sine of 2/3. Well, that's an angle whose sine, that's an angle whose sine is 2/3. Now, what does it mean if your angle has a sine of 2/3? That means that opposite over hypotenuse is 2/3. So if I have an angle here, I can put a 2 here as my opposite side and a 3 here as my hypotenuse. All right. Now, one thing that we can do here is, because just keep in mind, I want to get eventually the cosine of this angle, all right? So this is, let me maybe color code here. This is the angle that is equal to the inside, all right? So that's this angle that we're talking about here. Now, eventually I want to have the cosine of that angle. That's sort of the next part of the problem. So if I can find the adjacent over the hypotenuse, then I'm in good shape. Now, of course, we don't have the adjacent right now, but can we get it? Yeah, right? Because we can use a squared plus b squared equals c squared, right? And if I call this a, we'll get that a squared plus 2 squared is equal to 3 squared. So I'm going to get a squared plus 4 is equal to 9. So a squared is equal to 5. So a is the square root of 5. So now I can get the cosine of this angle because that's adjacent over hypotenuse, and I'll get a square root of 5 over 3. All right. So in this one, what we want to do is draw out a triangle that satisfies our inside function, and then we will fill in the missing side, and then that will allow us to get the trig function of the outside. Okay. Now let's look at something where we could potentially find a formula for cosine, tangent of inverse cosine of t. All right, we're going to essentially handle this the same way. So let's think about, if I want the inverse cosine of t, I want an angle whose cosine is t, right? And if I think of t as t over 1, then I know that adjacent over hypotenuse is 1, right? Because that's what cosine is. Now, if I draw this out, if I look at an angle here whose adjacent over hypotenuse is, t over 1, then I have that the adjacent side is t and my hypotenuse is 1. Now, if I want the tangent, I'm going to need the opposite, right? So we're going to need, one second, what's happening here? I think my thing's about to freeze. So let's see, reawake. Okay, let's try loading it up again. Okay, why aren't we working? All right, I'm going to pause this until this comes back to life. Oh, there we go. Let's see if it loads up now. Okay, so let's go back to where we were. Okay, so here we are. So again, just to bring you back where we were saying that my cosine, which is my adjacent over hypotenuse, is t over 1, right? So we said this was t over 1. So that means that my adjacent side is t, my hypotenuse is 1. Now again, if we're after tangent, I'm going to need the opposite, because I eventually want the tangent of this angle, which is opposite over adjacent, right? But if we're missing a side, if I call this b, then we know that a squared plus b squared is c squared again. And in this case, so we could say that t squared plus b squared is equal to 1 squared, which is just 1. So then b squared is 1 minus t squared. So then b is the square root of 1 minus t squared. And that's my opposite side. So now we can say that the tangent of theta is opposite, which is square root of 1 minus t squared, over adjacent, which is t. All right, so that's our formula for the tangent of the inverse cosine of t. Okay, so hopefully that's not too bad. The key of these is to draw out the triangle and then fill in the missing side, essentially. Okay. Now let's talk about some of the inverse trig identities for negative inputs, right? So again, think about what the inverse trig functions are. So the regular trig functions have an angle going in and a number between -1 and +1 coming out. All right, so then that means that for the inverse trig functions, we have a number between -1 and 1 going in, and an angle coming out. All right, well, let's think about this. Okay, so now, for example, the sorry, not the domain, the range of arc cosine is 0 to pi, while the range for the other two is -pi/2 to pi/2. Right? Now, if you look at this on the unit circle, let me give myself a little bit more room. All right, now we're supposing that we have, let's look at the cosine case first. So inverse cosine of -t. All right, now for inverse cosine, we're only on the top half of the unit circle. All right, and I'm entering in some number between -1 and 1. So let's just say that this is -t right here. All right, well, cosine is the x value, right? And of course, in this case, it would be a negative x value, right? But the angle here would be some angle, which I'll call theta. All right, now if you look at positive t, that's just the one on this side, and that's going to be over here. All right, so this is the angle of, or I guess it would be the corresponding sort of value here, right? Now, of course, what's the relationship between these two? This one, this green one here, is the same as this one, right, by complementary angles here. And of course, we know that if I take theta and add it to the green one, which maybe I'll call alpha, I know that theta plus alpha has to be 180 degrees or pi radians. So that means that alpha, the green angle, would have to be pi minus theta, right? But we're calling theta the inverse cosine here, so this is just pi minus the inverse cosine of t. Right? And that's the only one that's essentially really weird. If you look at tangent and sine, you're on the right half of the unit circle, right? So now, if you enter in a negative t value, so let's say that's negative t right here, and this is some angle theta, well, then what's the corresponding value here for positive t? That's just going to come out in this end, right? Which is negative theta. Or sorry, not negative theta, but it's the negative sign that you found. Whatever this value is, this is the opposite. Right? So you're sort of seeing that happen for the sine, and a similar thing will work out for tangent. All right. Now, if we see this in action, we want to find the inverse cosine of negative cosine of pi/7. All right. And again, we want to use, we want to use the fact from up here that if I take the cosine of a negative angle, then that's pi minus cosine inverse of the positive angle, right? So that's just this identity right here. So in this case, if I want to find this inverse cosine, I need to find the inverse cosine. Now I'm going to replace this inside with pi minus the inverse cosine pi over 7. Oh, wait a minute. No, I'm sorry. That's not the way I want to do it. I need to do it sort of two separate things, right? Because I have, if I want to put it in this form, then my t is like this inside right here, right? So I need to do pi minus the inverse cosine of cosine pi over 7. A lot of cosines here. Okay, well now pi over 7 is in our range that we want, and the pi outside is just right where we need it. So we're going to get that the inverse cosine, the cosine of pi over 7 is just pi over 7. And now if we find a common denominator, we're going to get that this is 6 pi over 7. So that's the angle we want in this case. All right. Now, as a next example, let's look at this one here. So in the first one, we want to use the fact that the inverse sine of a negative angle is just negative of the inverse sine of that positive value. So I need to find, in order to do inverse sine of minus sine of pi over 7, I need to take negative inverse sine of pi over 7. And of course here, pi over 7 is between negative pi over 2 and pi over 2. So here I'm just going to get negative pi over 7. Okay. Now the second one is a little bit different because now the inverse sine is on the inside. Okay, so what we have here is now this inside is of this form of this identity. So now I'm going to get a sine. And what do I do here? I need to take the negative on the outside and do the sine, the negative sine, inverse sine of positive 2 over 5. Well, now here we need to use the fact that if I have sine of negative x, that's negative sine of x, right? So that's just the old identity from before. So this is negative sine of inverse sine of 2/5. And you can check that 2 over 5 is between negative pi over 2 and pi over 2. And here you will get that this is just negative 2 over 5. Okay, so that's what we get for that one. Okay, now the last identity that we'll talk about in this video is the identity where the inverse cosine of an angle and an inverse sine of an angle, the inverse cosine of a number between -1 and 1 plus the inverse sine of a number between -1 and 1 is always pi over 2. Okay, now you can always show this, right, by let's look at the unit circle. And let's say that my t value is just say somewhere right here, for example. Right, well, if I look at this and bring this triangle out here, let's say if I call this theta, if this is theta, this is pi over 2 minus theta, and this is my right angle, right? So we know that for any number between -1 and 1, my t value will look something like this, right? So I'm essentially adding this angle to this angle, because if I were to take the cosine of theta, I would get a, so let's see, how do I want to say this? So I would get a, let's put it this way, that theta is the inverse, sorry, this should be inverse sine of t, and that theta pi over 2 minus theta is the inverse cosine of t, right? And of course, if you add these together, you're going to see that you're just going to end up with pi over 2 is equal to inverse sine of t plus inverse cosine of t, which is exactly the identity that we have, right? So anyway, we're going to verify the identity when t is equal to a half. So if t is equal to 1/2, we want to show that the inverse cosine of 1/2 plus the inverse sine of 1/2 is equal to 1. Now, if we look at a triangle that has a 1/2 involved, we'll have the 1/2 is across from a 30-degree angle. Square root of 3 over 2 is across from a 60. And then we get our 90-degree angle there. All right. Well, what's an angle? This should be pi over 2. What's an angle whose cosine is 1/2? Well, cosine means adjacent side. So this is a 60-degree angle here. What's an angle whose sine is 1/2? Well, that's the 30 degrees. And of course, if I add 60 and 30, I get 90 degrees, which of course is pi over 2. All right, so that's how we can sort of verify that identity. All right, so that concludes this section on inverse trigonometric identities. Hope you enjoyed, and I will see you next time.